Let's work with doing some transformations to this mystery function g of x. We're going to use g of x as the parent function, and then we're going to do some transformations to it. So the first thing I'm going to do is go through and I'm going to identify the domain and the range of my parent function, and I'm going to label ordered pairs for each of the dots that are shown here, each of the points. So I'll go ahead and label these 1, 2, 3, 4, 5. So this is -5, -2, -3, 0, -2, 0, 0, 2, 2, 0, and 1, 2, 3, 4, 5, 6, 7, 8, 8, 3. So domain, we're going to scan the graph from left to right. The first x value we come across is right here at -5, and it's continuous all the way through the last x value of 8. Since there are closed circles at both of the endpoints, the domain will be from the bracket of -5 to 8, again with a bracket because of the closed dots. Range, we'll scan bottom to top. So the first y value we hit is -2, and it goes all the way up to 3. So -2 to 3. Again, we have brackets because of the closed circles. So we're going to keep this function handy while we look at some transformations that we're given. In our first transformation, we are asked to find 3 g of x. Now this transformation is 3 times g of x. That is a vertical stretch. So in order to take our mystery function and do a vertical stretch, what we're going to do is we're going to multiply each y value, multiply the height, which is the y values, by the value of the stretch, which is 3. So each of my ordered pairs, -5, -2, is going to be -5, -2 times 3, which is -6. So my first ordered pair, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. -5, -6. Then my next ordered pair will be -3, 0. Multiply the 0 by 3, so it's -3, 0 still. -2, 0 also remains the same. 0, 2 will become 0, 6. Multiply that height by 3. 2, 0 still remains the same. And 8, 3 is going to become 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. Now when I connect my dots, I want to make it have the same type of shape as the parent function. So I'll connect these with a straight segment, straight segment. This is going to be kind of a roundish because it was like a semicircle. So make it round, and then a straight segment. I want to figure out the domain and range of my new function. Scanning from left to right, my lowest x value was that -5 here. My highest x value went all the way over to 8. And for range, lowest x value is now all the way down here at -6. So -6. And the highest y value is all the way up here at 9. So -6 to 9 with brackets. The next transformation that we're going to do is 1/2 g of x. Now that is a similar problem to the one we just did, except for this is a vertical compression. But we handle it the same way, so I'm going to multiply each of my y values by 1/2. So -5, -2 becomes -5, -1. -3, 0, and -2, 0 stay the same. 0, 2 becomes 0, 1. 2, 0 stays the same. And 8, 3 becomes 8, 1.5. And then 1.5. Connect the dots, straight, straight. Oops. Make it a semicircle, and then straight. Domain, again, did not change. So the domain is still -5 to 8. But the range now goes from -1 up to 1.5. So the range, -1 to 3/2 or 1.5. Okay, the next transformation is going to be -g of x. Now, -g of x is a reflection over the x-axis. So each point is going to just mirror over the x-axis to the other side. So what we're going to be changing, instead of being at -5, -2, when I reflect that over the x-axis, it's going to go up here to -5, 2. So all we're going to do to reflect over the x-axis is we're going to change the sign of the y values. So -5, 2 becomes that ordered pair. -3, 0 stays -3, 0 because 0 doesn't have positive or negative. -2, 0 stays the same, so does 2, 0. But 0, 2 is going to become 0, -2. And 8, 3, 8, 3 becomes 8, -3. So connect the dots the same way. Straight line, semicircle, straight line. And we want to look at domain and range. So scanning left to right, the lowest x value over here is still at -5. The highest x value is still out at 8. Range, the lowest y value hits at -3, and the highest y value hits at 2. So the range will go -3 to 2. Let's look at the other type of reflection now. G of -x. So the difference here is that the negative is now inside with the x, which